This is part two of a three-part series where I'm digging deep into growth models and helping you to understand different pros and cons and why Arkansas does what it does with the current growth model. So in this session, I'll cover some of the simpler models and talk about the pros and cons these have. In session three, I'll dive deeper into Arkansas's value-added growth model and share actual Arkansas data visuals that help explain why we use it over the models I'm going to cover next. In my 20 plus years of working with Arkansas data, I've actually experienced the simple models and also the complex models for measuring how students are growing in their learning, in their achievement. Simple on the surface comes with trade-offs for what lies beneath. And typically we ignore those trade-offs, at least we did during NCLB. But we know better now, so we're doing differently now. Let me explain. Let's start with the simplest form. These are gain scores, and you saw that a small percentage of states use these. There's a reason that only 6% of states use gain scores. You have to have almost a perfect scale for your assessment, and that's impossible to achieve, or very difficult and expensive to achieve. And that can also come with other trade-offs. In a gain score, it's basically what was my scale score this year minus my scale score last year. And that is the simplest. It's very transparent, but it comes with some assumptions that are incredibly hard to meet. Equal intervals in the scores on the scale within and across each subject and across the grade levels. That's difficult to do even in a highly technical scale. This also assumes that the gain at all points along the scale is equally achievable. I think this is the one that we tend to ignore the most because we just think it's like a number line. It looks like a number line, but it's not a number line. Sometimes, and we've seen this in the past for most tests, making 5 scale score point gains at the lower end of the scale is easier to accomplish than making 5 scale score points at the top of the scale. So if we don't have a perfect equal interval scale, and we can't say with confidence that gains at the low, middle, high end of the scale are equally achievable, then we set up something that's a little unfair when we use it to measure a school's impact. In addition to that, there's a whole literature on measurement error inherent in scores. This is the standard error of measurement, and it's not the same within and across subjects and grade levels at any point on the scale. We know this from all the research that's been done on it in the past. This simple visual gives you a sense of gain scores and how it might be easier or harder to move at different parts of the scale. So if I look at students, so it basically shows 0 as a student getting the exact same scale score as they had in the past. That's their difference. And then on the left-hand side, it shows you the standard error of measure, the conditional standard error of measure that's associated with that gain score. So that tells you kind of the confidence we have around the exact score that we're using. Now, this is technical. The pro of a gain score is it's simple and easy to calculate and aggregate. The con is the assumptions aren't met. So that means error is different. The gain score error is larger than the error of either point in time. And you can see from this diagram that there's more error around the change in achievement around the middle. So students who've lost 2 scale score points, students who've gained 2 scale score points from one grade to the other. That means if we don't account for it, which you would if you were being responsible, it means that you could incorrectly think one student is not gaining, but in fact, their gain score has so much error in it, we just really don't know if they're losing or gaining. So that's really important, because if we did then apply error to our gain scores, what does that do to the simplicity? It complicates it. And this is the truth underlying these more simplistic models. To make them fair and accurate and precise, we have to do more complicated things in order to achieve that. So if we know that the differences in individual and aggregated gain scores may lead to incorrect inferences, and we don't put those extra layers of complicated calculations, then we are actually biasing the outcomes for our schools. So this is a really important piece to understand. We had this problem with our original benchmark and end of course assessments during ACTAP in Arkansas, where math had a 15-point gain was twice the gain that a 15-point gain was for literacy. That was for real. That was the data. Let's talk quickly about growth to standard, because this is one of the ways that we tried to tie proficiency to growth, and this was early in NCLB. We piloted this type of model in 2006. These are called criterion reference growth models, part of the early growth model pilot programs for No Child Left Behind, and it was required that you tie it to achieving proficiency. States experimented with various ways to do this, from the growth to standard trajectory, which Arkansas did, and then the categorical value tables or transition tables, which Arkansas did for state accountability. And then some states used adequate growth percentiles. Growth to standard, the one that we used in Arkansas, was trying to be responsive to providing a measure that was over and above safe harbor, just changing the percent of kids proficient. Under NCLB, there was no workaround for this proficiency, so all pilot growth models had to tie growth to proficiency. We used this trajectory approach that was projecting where a student needed to be on the scale each year, each grade, in order to be proficient by grade 8. So it was time bound for sure, and proficiency was set for grade 8. And when you look at this diagram, notice in the picture that if you were below proficient, down here a red or yellow line, then you could get credit as if you were proficient if you were at your trajectory point, at or above it. So the black line is how students' scores on average changed over time. Notice there was a lot more growth in 3rd and 4th grade than there was in 5th and 6th, and even less from 7th to 8th. But also take a look at these students who were super high performers, this green line. What happened is these students could literally lose ground over time as long as they didn't cross this line. And that became a problem because these students often languished. As long as you didn't lose too much ground and were still proficient in 8th grade, you counted as a proficient student. So there was no incentive to accelerate students, to ensure that they were being challenged across the board. Now, here's an example of a value table. And what we know about value tables is that they are and appear to be very simplistic. So a comparison of a student who's on track versus a student who's not on track, these determinations come from these different types of models. So in this case, these were piloted also during NCLB, and approximately, I think it's 24 or 26% of states still use these. One of the reasons they use them is because teachers can look at the table and know that there's a particular score that a student needs to cross over in order for them to get higher points for that student. Some models, and you can see here's 4 different models, they all differ. The most popular models are models that give points for upward growth. Some of them give upward growth in the lower levels and also upward growth in the higher levels. and also give you credit for staying the same. Other models give you upward growth only at the bottom, at the low end, and give you the same amount of points once a student has achieved a certain level of proficiency or higher. And one of the issues that we run into with these is that these actually tend to create issues because the scale, remember all the things that I pointed out to you about gain scores, that those are the same issues underlying these tables. These are tied to criteria, but often you have to split each of these achievement levels. Like in Arkansas, we have levels 1, 2, 3, and 4. And there are differences at those levels in terms of what they mean for that grade level and that subject. But the transition table or value table doesn't take that into consideration. So often they'll split these values almost equally at the lower and at the top. And although it looks like you have a score to shoot for, number one, it's a false narrative, I will tell you, because of all the things I pointed out in the very first session of these videos, in video number 1. And that is that having a scale score target does not directly translate to what that means for teaching and learning. It's a point on the scale. What you have to do to make students change in their achievement is you have to get deeper into the standards and the expectations. And so it's a false sense of having a target. What's more important to pay attention to is the information you're getting out of the assessment. And particularly since we have Atlas, it's so much more information that's useful. You know, which standards are my students actually demonstrating a high level in, and where are they struggling? That's the information you need to attend to. The goal that you might use to get over a line in one of these charts doesn't do that translation for you. It's just an extra piece of information. It's not actionable, as some people like to say. So it's important to know that even though these value tables appear simpler and more transparent on the surface, additional cut scores are added arbitrarily on the scale. They're not done through the same standard setting, criterion-based process, which means they are relatively arbitrary, and they don't account for the differences in how students are able to achieve at different points on the scale. So the values in the table, they matter a lot if they're not reflecting those differences and they're just based on criteria tied to standard. They are doing the same thing that the achievement levels do in the first place. They don't provide additional information. The other thing that you need to know is that prior achievement is so strongly correlated, so strongly related to current achievement. That means who you serve matters. So if your kids come to you behind, there's a small, that correlation explains a certain amount. I'm going to give you the exact data in my last video, in video number 3. But that strong correlation matters, which means that if you serve a lot of low achieving students, you're not going to see gigantic gains in achievement, and you're going to have to really make kids cross lines. That's a disadvantage. It's also different across subjects and grades. And so that becomes an incredibly important part of this. So you end up with point tables that you have to work with, and then grade level cut scores by subject that you have to work with. So the simplicity is, in theory, due to the transparency, but it still requires an incredibly deep set of business rules and tables in order to translate it. And that's time better spent focused on the standards and teaching the standards and ensuring students are demonstrating a high level of proficiency on those standards. I'm going to sum this up by saying that if we're going to use the transition tables, They have the same issues with gain scores. The assumptions are that the scale behaves the same from the low to the high end, that it's equal interval, that the scale is the same across subjects, and that achievement gains across grades is accounted for in the background, which leads to additional complexity. It's just not the public-facing part of the complexity. And when we want to be fair, we need to account also for not just students moving up, but students moving backwards, because that was a lesson learned when we were using these criterion-based growth metrics during NCLB. If we didn't pay attention to kids moving backwards, then our students lost their high achievement over time, which meant that they could get all the way to high school and actually be at a lower level of achievement than they were when they started in third grade. And that's really sad. That's just sad. So we've got our cut scores here for ELA, math, and science. You can see that we would have to create smaller cuts below the blue line, cuts between the blue and the orange line, and there's not a lot of scale score points there. So it's kind of a false sense of progression, and it doesn't capture all growth. For a student, it captures just growth over these lines and the smaller set of lines, which refocuses people on bubble kids, which is unfortunate because, again, it's really about all kids learning. So that's just a high-level overview of the criterion referenced and scale referenced simpler models. In the next video, video number 3, I'm going to dig deep into Arkansas and make my case for why what we're doing in Arkansas, by far the pros outweigh the complexity, which seems to be what people think is the biggest con. So see you on the next video.